Thank you so much to everyone to be here. My name is Christian Dominguez. I'm from the Centro de Ciencias Atmosféricas from Mexico. And today I'm presenting tropical cyclone and easter wave relationship in regional precipitation over the tropical and subtropical North America. So I would like to begin asking, what is an easter wave? I don't know if many of you are familiar with this tropical phenomena, but an easter wave is a wave that is composed by a positive phase that is represented by a low pressure system where you can find precipitation, clouds, and ascent movement. And the other phase is a negative one where you can find a high pressure system. And you can see here there is subsidence and there are clear skies. So these tropical phenomena are commonly recognized as the precursors of tropical cyclones. But for example, the precipitation that these tropical phenomena produced haven't been analyzed. So in this study, we analyze how the easter waves produce precipitation over the tropical Americas and how this precipitation can vary over the northern South America. We also explore how the tropical cyclones can induce different vertically integrated moisture flux in the subtropics. So first, I would like to present how important easter waves are for the tropics. For example, here you can see that the easter waves can produce up to 700 millimeters over the Eastern Pacific Ocean. And for example, these tropical phenomena are very active over this basin. For example, they can also produce up to 60% of the seasonal rainfall over the Central America. But for example, over the northern South America, they can produce up to 30% of the seasonal precipitation, which is very important. We also see that in some years, for example, 2013, you can see here that the blue line represents the number of tropical cyclone days over the main developing region. And the red line represents the number of days of easter waves over the northern South America. And you can see here that these are like an opposite relationship here. So the more number of easter waves can produce more seasonal rainfall. But for example, just look at the year of 2005, that was a very active year in terms of the tropical cyclone activity. You can see here that the number of tropical cyclones over the main developing region is higher, but the number of easterly waves over the northern South America is low, and also the precipitation. So we propose an easter wave tropical cyclone relationship. So we have hypothesized that the tropical cyclones that occur over the main developing region are developing from easter waves here. And these tropical cyclones will tend to recur into the subtropics. So they will transport all the moisture from the tropics into the subtropics. But for example, the easterly wave that was supposed to be here, but it's not because it's a tropical cyclone, is not producing the precipitation. So the accumulated regional precipitation over the northern South America will decrease when we have years with a very high tropical cyclone activity. So you can see here that we prove our hypothesis. We analyze years with a very high tropical cyclone activity that is represented here by letter B. And we also analyze years with a very low tropical cyclone activity. So in this column, you can see the precipitation that is produced by the easter waves. So in years when we have a very high tropical cyclone activity, the precipitation produced by easter waves is decreased. But for example, here in years with a very low tropical cyclone activity, you can see here that the easter waves produce more precipitation because all the humidity goes to the northern South America and the Caribbean region. But for example, in years with a very high tropical cyclone activity, you can see here that most of the moisture goes to the subtropics. And we also find that this relationship is only held during neutral years and also during the positive MAO, because the ocean is warmer and also the vertical wind shear is decreased. As you can see here that the negative MAO phase occurs the opposite. For example, the ocean is colder and the vertical wind shear is increased, mainly the main developing region, which are like the environmental conditions are unfavorable for the tropical cyclogenesis. So this relationship is not held during this phase. We also analyze how the regional climate simulations reproduced the easterly wave activity. And we create this ensemble by combining different radiation schemes, cumulus parameterization, microphysics, and boundary layer schemes. So you can see that in some letters, some members of the sample, they reproduced very similar easterly wave activity. For example, the letter E and the letter F are similar to the easterly wave activity that is represented by the ERA interim reanalysis. And we also explore how the different members of this ensemble reproduce the contribution of easter waves to summer rainfall, which is an accumulated rainfall from May to November. So you can see here that some of the members like letter F, letter A, letter G reproduced contribution that is similar to the rainfall, to the contribution found in the ERA interim reanalysis. So far, we have here a quick summary. So accumulated seasonal rainfall depends on the easterly wave activity, since they reproduce up to 50% of the accumulated summer precipitation over the northern South America. More TC tracks the curve into the mid-North Atlantic transport more moisture into the subtropics or mid-latitudes, and this reduces the chance of rain over the continental tropical Americas. Because the number of easterly waves days reaching this region is reduced. The opposite effect occurs under low tropical cyclone activity over the main developing region. However, this relationship is overwhelmed under strong El Nino or La Nina events, and it's only valid under positive MAO conditions. Whereas the simulated easterly wave precipitation over land is poorly represented, the easterly wave contribution to seasonal rainfall over tropical Americans landmass is adequately captured by most of the members. So if you have any questions, please reach me out by email or follow me in Twitter. I will be very happy to read your questions, so just let me know. Thank you so much.